Hello, everyone, and welcome to today's webinar on large language models versus traditional machine translation systems, a quality and cost comparison that Intento is doing together with XTM. My name is Daria Sinitsina. I'm the lead computational linguist at Intento, and I'll be the moderator for today's webinar. All right, I think that's it from my side. Now I'd like to hand it over to Andrei to introduce himself.
Hi, hello everyone. My name is Andrei Zidoroni. I am co-founder of XTM International. 50 years in IT and 35 in NLP and localization related IT tasks. So I bring a whole load of experience to today's webinar. Thank you.
Perfect. Gregory.
Hi, everyone. I'm Grigory Sponov. I'm CTO and co-founder of Intento. I have less experience than Angie, but I still spent a great deal of time in IT, NLP, deep learning, and so on. I have PhD in AI, and this field is really fascinating. So hopefully this webinar will be interesting for many of you.
Perfect. Thank you, Gregory. Thank you, Andrei. We have wonderful speakers today, and we're going to discuss a lot of very interesting things. We're going to go through some things regarding quality and RAG when it comes to LLMs. We're going to discuss some interesting things like AI agents, AI multi-agents that a lot of people probably already started to hear about. And of course, we're going to touch on things like cost, language coverage, security risks, and technical considerations when it comes to using large language models versus machine translation models. Before we actually dive in, I think it's a great time to look at some very interesting insights from our State of MT report, because we've taken a look at both large language models and machine translation engines when we assess them. And this year, State of MT revealed significant shifts in the translation technology landscape. The past year has marked a dramatic transformation for machine translation because LLMs started to appear more and more. This year in May, when we prepared the report, we tracked 94 vendors in total, and large language models have nearly doubled the presence from 2023. So in 2023, we had 18% of all vendors be LLMs, and this year it's around 35%. And you understand this is a big change. Even more interesting and striking is how the performance has changed. Large language models now represent 55 or more than half of top performing models, which was around 15% in 2023. Interestingly and importantly, the quality landscape is not straightforward. Our analysis showed that only in about a quarter of cases, large language models significantly outperformed machine translation engines, mostly in such hardcore domains as colloquial or educational content. However, interestingly, traditional machine translation still holds the ground in a lot of areas, notably for mid-resource languages or domains that are slightly easier and have more data for machine translation agents to be trained on. Also important to note that in May 2024, when we've done the analysis, open source large language models still mostly appeared in the second tier quality-wise. That might have started to change with Llama recently, but we don't know much about this yet. Also important, and we're probably going to touch upon this later on today, is that large language models and machine translation actually make pretty much the same mistakes translation-wise nowadays. Last year, we've noticed a lot of hallucinations. This is not the case this year, almost at all, which is awesome and very interesting for us. So it's mostly omissions, additions, mistranslation, something that is very familiar for all the people in the translation industry. Each system, of course, has its unique quirks and strengths, and weaknesses. And this is what we're going to discuss here today. And I do have a first question that I'd like to start with, and that is, what benefits do you yourself see from using large language models when it comes to quality? And Andrzej, if you don't mind, we're going to start with you.
I think the most intriguing one is around both performance and cost. The costs for using large language models for translation are significantly lower than traditional MT. That's what we found. I think that was corroborated by your excellent report, which I always read cover to cover every year. Whenever they come out. No, that's an excellent piece of work and fantastic detailed comparison. The flexibility, just the fluency is outstanding. Also, the lack of the kind of traditional trip up things that have always bothered MT systems, like out of vocabulary words and things like that. Yeah, it's just outstanding. When I first of all encountered Da Vinci from OpenAI in 2021, 2022, I think my bottom jaw dropped in terms of the fluency output, obviously in major languages. So I am 100% bilingual in English and Polish. So, and I had a great privilege of living for 6 years in France. So, trying out French and Polish, it was just outstanding. The fluency. What really got me was its ability to translate. The hallucination on the source language was an issue. But as you say, this is kind of slowly diminished, especially with the new O1 model from OpenAI that's coming out, that's being kind of accidentally pre-released, but also for O1, that these were really, I think they got to grips with a lot of hallucination issues, but no, phenomenal.
Very true, very true. And hallucinations wise, we were surprised ourselves because this is something that we've kind of tried to find this year in the MT report, just to kind of showcase the difference between the traditional MT engines and the LLMs, just because this is assumingly the biggest difference that we're supposed to see. But no, not anymore. I mean, of course, there is still hallucinations happening for smaller models. Larger ones, I haven't seen them in a while. Gregory, what do you think?
I completely agree with Andrzej. Performance and quality and price are really great. So LLMs are disrupting the field, and we know that some machine translation vendors already switching to LLMs inside. So the boundary right now is not clear. Sometimes you use MT engine, but there is an LLM besides the API, and you might just don't know that. Yeah, it's really good. With price, it's really interesting. We'll touch it a bit later. The price is great, but the pricing model is really complex, and there are very many dimensions and moving parts here, and it's important to understand. I prepared a slide. I will show it later when we touch this topic. I'd highlight the main benefit of LLMs from my experience is it's the great adaptability. There are different modes of learning. You can use prompting with instructions, and you can vary instructions a lot. Right now, models support large context sites, and mega prompts are already here, so you can write really big prompts for several screens. For example, Anthropic Claude has an internal system prompt for like 2 screens of English text. So that's interesting on its own. So you can use prompting and instructions, and you can easily adapt your instructions dynamically, looking at type of errors and looking at what works poorly. And it's really great. You don't have to wait days or weeks to retrain the model. You just update your instruction, test it, and hopefully it works. In many cases, it works. It's really great. Then you have an option to use few-shot learning, providing some examples. And again, it's great. You may not have a large data set to fine-tune a model, but you may have some examples. And these examples already provide some benefits and model produce better results. Again, that's really great. We can use retrieval augmented generations RAG. Again, we will touch this topic later. Beautiful topic on its own. And finally, you can use fine-tuning. Many different engines in the cloud provide fine-tuning options. You can gather some data set, not really huge, maybe thousands, for example, maybe tens of thousands, but that's already maybe enough for fine-tuning a model. And you can choose between different options. It's really great. That's not the case we had with traditional MT systems. Right now, the whole landscape of possible interactions with LLM is really enormous. It's beautiful. I love this field.
It's very true. I feel like when it comes to adaptability of large language models, this is one topic that when we discuss it, MT's very much behind at this point, even though machine translation excels in other fields when it comes to adaptability. I feel like we need to touch upon first RAG, definitely, retrieval augmented generation, just in case somebody forgets this topic. How has the integration of RAG changed the translation quality landscape compared to traditional machine translation systems? Andrzej, what do you think here?
A fantastic amount. These models are just so powerful that if you provide them with just a few short examples, they will use this. And I think we will have a short presentation on how to use large language models to provide adaptive MT. They are very, very skillful, and just, the quality just blows you away. This adaptive approach is almost the kind of holy grail for MT, because it allows you to fine-tune on the fly the translation, which completely obviates the need for retraining and everything else with all of the issues involved, i.e. retraining takes a lot of time, it's expensive, and also it's out of date as soon as you start retraining, because any new translations aren't being taken into account. So having the ability to actually effectively train on the fly using the genius of the large language models. But there are other things I think that Gregory will be able to expand on, with the ability to instruct the model to change gender of the output, things like that, the voice as well. These are kind of things that you can't do with traditional MT system. You couldn't prompt it. That's the main thing. You can just train it, and then once you trained it, that's your lot. You have to live with what you've got. Whereas large language models are so pliable, so flexible. I don't want to overuse this phrase, but we've cracked language. And that was something I was giving a series of presentations at ASLING TC conferences about 5-6 years ago, and I was alluding to the future where we'd be able to do these kind of things. And I was saying maybe 10-20 years time. It's here and now, so let's make most use of it, because they are fantastic.
Yeah, when you mentioned how we crack language, the first thing that comes to mind is that for how long have we tried to describe it in like rules and try to follow the rule-based scenario to train models, and now the more you give, the more they know. How surprising. When it comes to RAG, I think Gregory can say a lot about things that we've already started doing ourselves. I will just slightly mention here a small agreement with what you've said about RAG being used for style guides, for tone of voice, gender neutrality, et cetera, et cetera. This is so important when it comes to specifications of different enterprises and companies, overall, small and large, because previously we've had so many issues with stock or baseline machine translation when it came to formal versus informal tone of voice when they're used for real-time cases for chatbots, etc. And we would get so many complaints about the gender bias, which, as you know, still is a big thing, but we're trying to fight it now with LLMs. But Gregory, what do you think about RAG2, glossaries, fine-tuning? What do you feel here?
Yeah, RAG is a beautiful technology. It's beautiful in its simplicity. You just plug in some external data set, and finally, first of all, you solve the shortcoming of LLM. When you train, not you, OpenAI or someone else, train the LLM, typically there is a lot of time spent since they really trained it, and the moment when they delivered it in API or something like that. There are typically some security testing and so on and so on. So when the model is really available, it was trained on old data, maybe a year was passed since then, and it doesn't know new facts and so on and so on. RAG is a simple way of having a model access to the most recent data or private data you have inside the organization. That's really good. I said it's simple. It's may not really be such simple. There are many varieties of RAG, and there are pretty complicated settings when you can use RAG. But still, the idea is simple and beautiful. And it's funny, we understood last year, we used RAG for several years already with our glossaries. It works almost the same way. You prepare a glossary, you store it in some system, some database, and when you do translation, our software looks at the source, finds some specific items that exist in glossary, then retrieves a relevant part of the glossary, augments the prompt, or try to influence machine translation. And finally, the resulting translation is better than without this technology. So yeah, RAG is a really good technology. It solves a lot of problems, not all of them, but still a lot. And RAG adds a lot to adaptability of these models. Integrating with your internal systems that definitely wasn't available for any LLM vendor when they train their model is a big deal.
That's very true. RAG and fine-tuning and prompt engineering, all the things that we use to adapt LLMs, they make it better. And right now, we kind of showcase why LLMs are better in all the cases every time, 100% of the time. But I'm not sure that's particularly the case. When it comes to MT, machine translation, when do you think it still kind of outperforms or is used more than LLMs and would continue to be used more? Andrzej, what do you think here?
If you have a very, very specific engine that's been trained on your data, and you have an enormous amount of data, then possibly you've made the investment and that's it. But really, large language models blow everything out of the water. As you've mentioned, there are instances for particular cases where an enormous amount for a specific domain where things have been trained, but really, I find it kind of difficult to think of ways in which, neural MT engines would outperform LLMs now. It's just their flexibility. It's the fact that they do all languages. So you have things like OpenAI, 150 languages. Llama 3.1, something like 70 plus languages, and this is really well. In our statistics in XTM, obviously the #1 dominant language in the top 50 is a source language is English. I think German gets to look in occasionally, and but that's very, very low down on the list, something like number 30, 31, and then possibly Chinese. But the target languages, the top 10 target languages in commercial translation account for something like 90% of the volume. The other languages don't get much of a look in. The flexibility of the large language models is the ability to do across language. One of the things that we do in XTM is also the ability to actually translate from a kind of intermediate language, so say from Chinese into Chinglish, and then from Chinglish into English, and then out to everything else. So you have the concept of pivot languages, and the flexibility of large language models means that you can actually obviate the need for a pivot language quite often. You go straight out because there are so many ways in which you can mix and match the languages, and it just works. The Attention is All You Need paper that was published by Google in 2000. Gregor, is it 2016?
17.
17, yep. Was the kind of major breakthrough. But like most things, Google wasn't quick off the mark in being able to adapt it and actually commercially exploit it, whereas OpenAI, difference being, I think in the end of 2023, OpenAI had 250 employees and Google at that time had about 13,000. So they could turn on a dime, as you'd say in America, and deliver very quickly, whereas with large corporations, I know I spent 18 years at Xerox and 6 years at Ford. Things tend to move very slowly. So the other reason why large language models have been able to, really explode on the scene is that it didn't take a great deal in terms of manpower. You get brains like Grigory's, you get a couple of those together, and a bit of venture capital, and you can start sailing. Almost, not immediately, but within a very short space of time. That's it. That's my take on it.
That's true. The progress is very, very different, but Google is kind of, with the recent translational LLM that you might have heard of and adaptive MT that is part of it. They're kind of combining machine translation and large language models together, which I feel like in our current translation landscape, putting them against each other, even though that's the name of our webinar, putting them against each other makes sense, but I feel like making them work together is much, much better. So machine translation, of course, has some downsides compared to the large language models, meaning, again, adaptability, difference in tone of voice, adaptation, gender, terminology. Of course, it's harder, but we can still find a way to use them together. And I feel like this is a good time to give the word to Gregory and to showcase how they can be used together in a different pipeline.
Yeah, it's a good topic. First of all, right now, you still may have very specialized engines, machine translation engines, which are still good, and it's definitely an asset, and you may use it. And our approach is not to completely replace MT, but to augment it. And it's good to use models that deliver good quality. And there is an additional important theme, which is in which traditional MT might be better, is latency. Right now, LLMs are typically still slower than traditional MT systems, and it's likely won't be the case in 1 or 2 years, but right now there is some difference, and it might prevent you from using LLMs in some real-time cases. But in many cases, it's not a problem, and we see the speed of LLMs significantly improving. Again, we'll touch this topic later. What I want to highlight is that LLMs, not only MTs are typically, and even LLMs by themselves are typically suitable for high frequency problems, high frequency terms which appear in the data. And if you have something special, if you have, I don't know, some specific terminology which your particular organization use, if you have some very specific errors which are not present in the vast amount of data which is used for training LLMs and so on, these low frequency requirements are typically not satisfied with MT or even with LLMs on its own. So you have to compose something more advanced. And what I'm going to demonstrate here is a multi-agent system. What do we mean by a multi-agent system? Many real-world processes are already structured as multi-agent system. There are different people or systems operating different roles, and it's easy and good to transfer this structure to LLMs, to agents, and with agents you can have different specialized agents. For example, one agent can be proficient in being a good subject matter expert to use specific terminology the particular organization use. Another expert may be HR expert, which knows specific gender forms for different people names and so on and so on. But again, a picture worth thousands words. Let me share a visual example of how this may look like, and I think it explains everything much better. So what we did, we prepared a simple example of English text with typical problems with typos, with tags, with idioms, domain-specific language. Text you might face almost anywhere. And then we tried to translate it for some, even to one of mainstream languages. We choose Spanish. We have several examples for other languages as well. It works in many cases. So what typically you may face when you try to translate this text? First of all, if you choose bad MT or some default MT in some system, it doesn't matter in which system, you face a lot of problems. That's not the case we typically start with. It's just to highlight that only choosing MT is a bad thing. You have to carefully choose your MT. That's really important. Okay, we typically start from this, from the best MT inside some specific TMS. Okay, the best MT is significantly better than default MT or wrong MT, but still there are some issues. Typically, it depends on the specific type of text, it depends on specific engine and so on. And what's important that some information is completely outside of the MT. For example, machine translation just don't know the specific gender of particular person, and while in English that doesn't matter, when you translate to Spanish, to Russian, to Polish, to many other languages, that matters a lot. You have to choose carefully specific gender forms, for example, and this information is not available for MT at all. Or your company may use specific terminology, even if machine translation produce correct text, you still may use different words, different phrases for specific terms, and that may be important for you. You want to fix them. How you can do it? There are different ways. For example, you can assemble a workflow of several agents. Here, the first agent does translation, then we can ask a separate agent, let it be a reviewer agent, to look at the translation and criticize it, provide constructive feedback, and reviewer provides feedback, what can be improved in this particular translation. Again, this is done by LLM with specific prompts, specific instructions. You can tune these instructions based on your specific criteria, on your specific policies, and so on and so on. You may want to focus on specific items, don't focus on other items. But this was just a simple example with more or less default reviewer agent. It's already providing good deal of corrective feedback, and with this feedback you can ask the translate agent to improve translation, and it does it. the translation becomes better, but still there are some information outside of the translation process. No system knows about your particular organization, so you may want to integrate with your HR system, for example, and in your HR system with different names and roles, there may be gender pronouns mentioned, and that's useful metadata. You can provide this metadata to actually a special HR agent, AI agent may use a RAG to integrate with this database to retrieve all the important information. Right now it's pronouns, gender pronouns, and use it to update the translation, touching only parts which are relevant to this particular role, and that's it. And it's good. Right now we improved our translation. Right now we have correct gender forms when we mention specific people, but still not perfect. Okay, we can ask our subject matter expert agent to use correct phrases, words. It's more or less glossaries, but morphological glossaries, which support not only words, but some phrases. Again, this is a simple example, but it highlights the important topic. You may have different subject matter experts, and again, you can ask this agent, the subject matter expert AI agent, to improve the translation again. It does. Right now, it's even better. There are still some things that may be different from tone of voice you use, from your specific guidelines your brand manager wants to use, and so on. No problem. We can use another agent. Let be brand manager. It has a company style guide. You can use this agent to apply this style guide. Use formal tone of voice. Okay, it was already formal tone of voice. You can use some additional rules. For example, we want here to mention specific full names when you mention a role. It's technically not a translation. It's more than translation. Right now, you are rewriting text to adapt it to specific audience, to apply specific rules you want to use. And with this sequence of agents, it's much better. Right now, you improved almost everything, and it's adaptable. It's really great. And why is it good? Just because NMT cannot solve everything. Some of information is outside of the scope of MT. MT does not know your internal systems and cannot integrate with it. So LLMs are good in this sense, and agents built on LLMs are really a solution, and that's our approach. So you can use NMT for things where NMT is really good. It's correct grammar, linguistic quality, high frequency things which can be learned from data, but there are still a lot of other things. For example, negative feedback, what you should not do. It's hard to tell machine translation how to not do something, but it's easy to ask an LLM with specific instructions to not do something. You may incorporate low frequency requirements, context-dependent requirements. LLMs and AI agents typically better with consistency because they work with full text, not with single segments, which typically is a mode of operation for many MT systems. And still, there are some unexpected new requirements that will emerge later in the process. And again, that's important with AI agency and LLMs. You can easily adapt just because the nature of LLMs is highly adaptable. So that's really useful thing, and we believe this AI agents is a way to go, just because it's easier to fix different problems which cannot be solved by NMT, and also because it fits well with real life processes. And a separate but still important theme is sometimes it's easier to manage specific agents with a specific role than try to incorporate everything into a single MT system. It's still not possible. In many times, it's not possible. So that's what I wanted to share. A visual example helps a lot. It's better than having a lot
Better
of
than trying to
words.
explain everything.
Yeah.
Thank you, Gregory. Andrzej, what do you think about implementing such, multi-step solutions, and what do you think are the common kind of misconceptions about implementing such systems?
I think Gregory's described it really, really well. We in XTM kind of plan a more, no, a very similar agent type system where the first shot will go for translation via RAG. So we will, there'll be a short presentation on how RAG works within kind of our context. And then there is a computer-assisted review process, which is very similar to what Grigory described, which criticizes the output, just checks it. But then there is a human step, which is any fine-tuning, any adjustment that needs to be done. That's because the whole workflow, the whole agency is within the XTM workbench. It's planned to be. So the feedback is human feedback. So we're providing an additional level of feedback, but very much in line with Grigory's kind of description of the architecture. So agency, absolutely, it's a great idea. It helps to augment. And more importantly, it helps feed back into the system the corrections. So if the system, we can then provide the system with the updated examples and the corrected examples. So, yep, agents in large language models are featuring more and more. There are quite a few frameworks of. Actually, Crew is one of them. Atomic agents is another. It's gaining a lot of traction in general.
Understandably so. Understandably so.
Mm-hmm.
When it comes to agent workflows and when it comes to assembling systems like this, do you think there is still some, again, misunderstandings or misconceptions when it comes to it? So basically, maybe some people still think, OpenAI is enough. Let's just use API.
Oh.
We're good to go.
No, there's one of the reasons why a TMS like XTM exists is that, oddly enough, translation is the easy bit in comparison with all the other heavy lifting. So it's writing the filters, it's creating the workflows, it's actually extracting the text. Large language models or any NMT systems, etc., don't like inline tags on the whole. Okay, there are standard tags like HTML and DETA, etc., but there are also lots of non-standard tags, etc. So we have the extensive filters for everything from Photoshop, Markdown, any flavor of XML you wish, Microsoft Office, all of the formats. That's the heavy lifting. It's actually neutralizing the text and then the ability to put it all back in to the target format. Large language models and NMT systems work extremely well when they have clean text. If you have markup in the text, that really causes a massive headache for these systems. So you've got to view translation as a workflow. We had one of our customers in March sent us a note saying, that's it, we're cancelling our subscription to XTM. We're going to do everything via OpenAI. 2 weeks later, we got a request that they want to extend for another year. It sounds really easy. It's not. There's a
Definitely not.
Tower of Babel of different formats. You know, obviously, we have to cope with everything from FrameMaker to, you know, Dita, to various standards like COTI, which is a German XML-based component authoring standard that's kind of similar to Dita but different. So it's having the ability to handle all of these things. What we see more and more nowadays is basically on-demand, very short translation. So typically companies are moving towards CCMSs. So even all the major websites are all done in Adobe's various flavors of CMS. And so they're authored within a tight environment and then actually published from that environment. And then handling all of the pipework, the APIs that squirt the data through to something like XTM, then is able to apply translation memory. One of the things we didn't mention is that all of these systems have, how wonderful they are. They all use translation memory. Because why send it out to an engine when you have a previous translation? So that's a kind of thing that's often overlooked. Translation memory still plays an enormous role because it's such a powerful tool. The ability to spot what's being translated in an update. XTM has a concept of never-ending projects. Projects are constantly being updated, or JIT, just-in-time translation, where you start translating, and then during the time to market, the product undergoes multiple revisions. So typically in the automotive industry, they find out that if you only have 4 bolts on the wheel, the wheels fall off. So you've got to put 5 bolts on the wheels. So things like that, I've seen it all. So all of these things, it's the workflow, it's the heavy lifting that then is able to provide the text for the translation and then put it, very important, then put it back into its original format in the target language. And this is not trivial. Lots of people overlook it. It is the kind of hidden mechanics of the whole process of localization, easily overlooked, but fatal if you miss it out. You know, things like our customer who decided everything, large language models would do everything, and then found out it's not that easy, not that simple.
That's absolutely true. We do have some things to discuss as well, but I'm looking at the questions that we already got, and I think we can get to those things when we do the Q&A. But before we do the Q&A, we do have a small presentation from Andre from XTM that I'm going to share right now. And I hope I don't forget to turn on the sound. Okay, I checked it twice.
Hi, recent developments in large language model technology have made possible advanced machine translation that can dynamically retrain itself in real time based on translation memory and ongoing translator and reviewer work. Please join me in this short presentation where I will explain how this is all possible. Many enterprises use MT with custom models from commercial MT suppliers such as Systran, DeepL, Microsoft, Google, Amazon, and other top-tier MT providers, although they are typically very expensive to train, run, and maintain. The advent of large language model-based translation is set to revolutionize the MT marketplace. They can be significantly cheaper to run, especially the open-source models such as Meta's Llama 3.1, where the only cost is for hosting the model. LLMs can be an order of magnitude slower than traditional MT, but the advent of LLM accelerators such as the language processing units from Grok are rapidly removing this obstacle. Creating custom models for translation using LLMs is very time-consuming, expensive, and does not produce the desired result unless an enormous amount of data is provided, which for most organizations is not practical. They just do not have enough data. A custom model is also by definition out of date as soon as training begins because it does not contain any new data. There are other techniques for tuning models such as LoRa, low-ranking adaptation, where large amounts of data are not available, but again these require a lot of manual tuning which is not practical. There is though an alternative way of creating adaptive MT using LLMs, RAG, or retrieval augmented generation. Retrieval augmented generation, or RAG for short, is a technique that is used for chatbots that front-end a LLM. It is able to extend and enhance the LLM with external data, and this is of great significance that enables the creation of an adaptive translation system environment that can be tuned and updated on the fly. To understand how RAG works, we need to know a little about embeddings. Embeddings are a technique for ascribing numeric values to the words that make up a sentence, the basic chunk for translation. An embedding model is used to provide these values that encode the semantic values to each word. These values for each sentence, along with any metadata that we may want to record against the sentence, such as the actual translation, customer ID, date, time, etc., are written to a vector database. Embeddings ascribe a unique value to each word or part of word. For example, cat, dog, and mouse will have similar values that will be different from man, woman, child, etc. Similar concepts will have values that are closer aligned than dissimilar words like chalk and cheese. Using embeddings, we can find segments with similar meaning, although the text of the segments may differ. The first stage of creating a RAG-based adaptive translation for a segment is to calculate the embedding values for the text. We can then use these embeddings to find any semantically similar segments in the vector database. The search threshold values can be dynamically adapted according to need. Once we have retrieved the similar segments, we can then produce a prompt which is sent to the LLM to produce the required translation based on the examples provided, e.g., adaptive translation. We can also provide any terminology requirements in the prompt. If no similar segments are returned, we can still provide terminology in the prompt along with sample segments and add "please translate" in a similar manner to the translations provided. This is a very simple example of a RAG-based prompt for adaptive machine translation using Llama 3.170b on the Grok platform. Grok provides accelerated access using language processing units to open-source LLMs such as Meta's Llama and Mistral. Grok is only a hardware platform like AWS. It does not store or share any data that is sent to it. It does not train any models. This is perfect for many customers who worry about the privacy and IP of their documentation. The very low cost of LLM-based adaptive translation introduces many key opportunities. The ability to offer advanced MT at low cost is especially important for SME organizations as well as for enterprises. The NLP section of the Computer Science faculty of Dublin City University conducted extensive experiments confirming the viability of the adaptive MT LLM approach with output quality surpassing that of the very best MT systems. Adaptive MT is becoming a key new differentiator for improving MT quality. LILT, based on work from Stanford University, was a key pioneer in the introduction of adaptive MT. New players and adaptations of existing MT engines are now appearing. Doubtless LLM-based adaptive MT will soon follow. Thank you for watching.
Thank you, Andrzej, for preparing it and for not maybe not go through the slide like this. All right, perfect. We do have 10 minutes for the Q&A section. However, a small notice, before we go into that, you'll get, all the attendees will get a small poll on the screen right now. While I'm quickly trying to go through the questions, we do have a lot of questions to answer right away. All right. Okay, while the poll is still going on, so we don't lose the time, we do have around 10 to 13 questions open. We'll try to answer at least 5. I'm putting it as our goal. The first one that came in almost at the beginning of the webinar, I think each of us can answer. What about the cost of training large language models? And I feel like this is, if you don't mind, something that I can touch upon. Cost of training large language models is a very interesting question because there is 2 meanings. Either it's fine-tuning a large language model, which is not exactly very expensive, or the question is about training their own large language model. I'm assuming that's the first option. When it comes to cost of training, most engines that allow fine-tuning these days are not that costly. For example, if we look at the OpenAI or Gemini Google Vertex options, they do allow for training both the larger versions of their models and the smaller ones. So whatever purpose you have and however much data you have, you can kind of sample as much as you want to train a good enough model based on your data. But again, it's your decision whether to fine tune or to use zero shot to few shot based on your requirements. The next question that we have, the next ones are large, so I'm sorry that I'm reading them like this. Have you experimented with any large language model-based translation workflows that combine MT engines such as Azure Translator or Google Translate and an LLM to polish and fine-tune the translation from machine translation through prompts? Would this have any impact on quality? And again, this is, I feel like, a question that either of us can answer, but I already answered the first one. So Gregory, what do you think?
Yeah, that's definitely the case. And with Agent, we promote exactly this way. You can use machine translation, and in many cases, it could be good in many aspects, but still some aspects may be not perfect. For example, tone of voice, gender, some specific guidelines. And for this particular narrow things, you definitely can use LLMs to improve these particular aspects of quality. That's the essence of multi-agent approach. It's definitely a way to combine good things from different worlds. You may use any machine translation agents that suit your needs, but if it's imperfect in some aspects, you definitely want to and should use LLMs to improve that aspects. That's the way to go.
I feel like we've discussed today, and I feel like this is a great answer. The next question is from Leonid about XTM in using RAG and XTM. So Andrei, it automatically goes to you. If one already has a TM translation memory for a customer in XTM, can you use that translation memory within XTM as RAG for LLM? For example, can you use a prompt such as leveraging translations found in the translation memory for client X and not changing any ICE matches, please translate the following text. Does this integration already exist in XTM? And if not, do you have any plans to integrate it?
A great question. It's on our roadmap for 2025. So I've done all of the theoretical work. So I've got everything. I will start actually programming most probably in December. In spite of my age, I still love to program a lot. And we've got definite plans for introducing this in 2025, and they're absolutely definitely using the translation memory. So the concept is to vectorize all of the existing extant translation memories in terms of the source language, and then to use that to exactly produce, fine-tune the prompts, etc. We would never by default send ICE matches out for translation unless the customer requested. We had a setting that customer says, yeah, please include in context exact matches. Does everybody know what in context exact matches are? If not, I'll just give a very quick. Ice matches are very cold. That means that we have identified that this match has absolutely not changed during an update for a project. So if a project document is being updated, we can identify all previous translations, and those translations are kind of, the customer has the ability to lock those translations so that they don't go out to the translator. The translators have them locked as well, though this can be overridden. So you can override ice matches if required. So, yep, the answer is 2025. Very much on our roadmap.
Perfect. Thank you so much, Andrzej. And done with this one. Another one is a quick question about the demo that Gregory shown before. Hello, everyone. First, I wonder if you call different large language models for different language tasks, or is it basically the same large language model?
It may be both. You technically can use any model you want, and if some model works better on specific task, definitely that's the way to go.
Perfect.
No restrictions.
Second, sorry, I'm trying to like quickly go through them. Second question. Did you have to specifically annotate or maybe even restructure your internal data to make it better available for RAG? I mean, yes, I feel like when you use RAG, you cannot just streamline the whole data that you have and have LLM just choose whatever you need. I feel like you do need to restructure something to use RAG.
Yeah, I can add to that, Daria. Yeah, so first of all, we need to align typically at the segment sentence level. So you need to have perfect alignment, and in order to do alignment properly, you obviously need a process that is able to cope with your data, so it can filter out the text from the source electronic format, align it at segmented and align it at sentence level, and then actually you need to write it away to a database, typically translation memory database, and then you use it from there to actually create your prompts. So during writing to the translation memory database, you would vectorize, create vector embeddings of the source sentences that allow you to also do lookups to find similar sentences to add to a prompt for RAG. So that's my bit. Thank
you. Perfect. Thank you so much, Andrzej. One last question, sadly, but we do have more and we'll probably answer them afterwards. What kind of, and that's a very interesting question for me, what kind of professional profile would be responsible to update and instruct AI agents in the multi-agent system? Would one be needed at every company? Gregory, what do you think?
I think there are several ingredients. First, you need you need domain expertise to understand what should be changed. That's really important. Second, you have to be a prompt engineer. It's a very diverse set of skills, and it's changing right now, but it's still important. And having if you have a linguistic education, that's definitely benefit you a lot. Summarizing this, you may have this skill set in a single person, or you may have this skill set together in a team of different persons. So the trend here right now is many systems, many user interface go towards simplifying instruction agents and trying to help you a lot. Sometimes LLMs can help you generate instructions and so on. So finally, we'll see a simple user interface where you can adjust what you need, but still there are some experts inside your company or outside that can improve, can help you build the right pipelines a lot. Or if you have your own experience with prompt engineering, it's also a way to go.
I can add a few very important tips for prompt engineering.
That's
Number
that's
one,
gonna be perfect conclusion for the webinar. Thank you.
large language models really respond well if you're polite. So if you say please, they also have in the past shown amazing improvements if you offer them a bonus. So if you say, can you do this, please do this, and if you get it right, you will be in line for a $10,000 bonus. Oddly enough, this has produced better results in the past. Whether it will going forward, I'm not sure. But one kind of final takeaway for people, obviously large language models aren't really artificial intelligence in its correct sense. And I can talk for hours on what constitutes proper artificial intelligence, as Gregory would as well. But it's important to note that what they do is encode knowledge. And this is a kind of precursor to general artificial intelligence. So if you think of how you would encode knowledge, from the computer science point of view, this is an incredibly difficult task. So what we've accomplished by just taking a massive hopper and loading up basically the sum of human publications, we have created a repository for knowledge, which can then be used going forwards for creating many, many incredible things. So that's my little bit
Perfect.
to conclude the
Yep.
webinar.
And as I said, I feel like a perfect conclusion out front. Also, by the way, a tiny addition for me: if you tell a large language model that you're going to lose your job if it doesn't complete the instructions correctly, that might work sometimes as well. I tried it, and I'm still here. All right, perfect. Thank you so much, Andre. Thank you so much, Gregory, for this wonderful webinar, and thank you for all the attendees. Hope you have a wonderful evening or morning or day wherever you are, and see you next time.
Thank you.